All right, let's jump right into this explainer by confronting a massive, terrifying problem for tech giants like Amazon or Instagram. Think about it for a second. A 10-minute application downtime can mean millions in lost revenue and a completely ruined reputation. We all just expect our apps to be perfectly reliable, right? Available 24/7, no excuses. But making that happen behind the scenes, well, that requires a highly sophisticated, incredibly well-oiled machine. Let's look at exactly how it's built. So, the absolute core takeaway here is that true DevOps maturity is a journey. You build it layer by layer. And to build these massive, scalable systems without that dreaded downtime, we have to start at the absolute bedrock. As one of our sources perfectly states, you cannot automate what you don't understand. And here's the reality. Most DevOps tools, from containers to cloud virtual machines to Kubernetes nodes, they run entirely on Linux. If you don't truly understand how the underlying system works, you simply can't confidently operate across those higher DevOps layers. Here is our roadmap for the journey today. We'll start with foundation, Linux, and scripting. Then orchestration, Kubernetes deployment strategies. Next is visibility, monitoring with Prometheus. And finally, the future, predictive AI ops. Section 1, Foundation, Linux, and scripting. Let's start with the base layer, because almost all modern infrastructure runs on Linux. When you log into a production server, you aren't going to find a nice graphical user interface with a mouse. You are greeted by a blank terminal, and you need to know how to speak its language. Since Linux servers don't give you that GUI, knowing how to talk to the system via the shell is completely mandatory to prevent tedious manual work. Imagine your boss asks you to create 100 specific files on a server. Doing that manually would take forever. Shell scripting allows you to write a simple script that automates these day-to-day administrative activities instantly, which makes you an exponentially more efficient engineer. And this is a brilliant way to think about the file system. It's literally like your base Google Drive folder. Just like Google Drive has a parent location where you organize all your personal folders, Linux uses the root directory, represented by a simple /, to branch out into all the various system and user folders. Every single thing on your server lives somewhere downstream of this root. To navigate this file system, there are exactly 20 fundamental commands every DevOps engineer relies on literally every day. Let's do a rapid fire rundown. You use ls to list directory contents and see exactly what files actually exist in there. You use cd to navigate straight into a specific project folder. You run pwd to print your working directory when you inevitably get lost in the tree. You use mkdir to create a brand new folder for organizing your system logs. You use rm to remove old temp files and free up space, but please be incredibly careful you don't accidentally wipe the entire server. You use cp to quickly copy a configuration file so you have a safe backup. You use mv to move or just rename an incorrectly uploaded file. You use cat to print the entire contents of a script right out to your terminal screen. You use grep to instantly search through massive log files to find a specific error string. You use find to locate a missing SSL certificate that's hiding somewhere on the server. You use chmod to grant execution permissions so your brand new script can actually run. You use chown to change folder ownership over to the application user. You use ps to view all running processes and make sure your app hasn't completely crashed. You use kill to forcefully stop a zombie process that is just hanging the system. You run top to monitor live system resources and instantly spot dangerous CPU spikes. You use df to check your overall disk space so your main drive doesn't hit 100% full. You use du to estimate file space and figure out which specific folder is eating all your storage. You use wget to pull down new software packages directly from the web. You use curl to ping an API endpoint to make sure your web server is actually responding. And finally, you use SSH to securely log into a remote production server to actually start all your troubleshooting. Mastering these 20 commands basically makes you unstoppable in the terminal. Section 2, Orchestration, Kubernetes deployment strategies. Now that we understand the single server and how to navigate it, let's scale things up. We need to figure out how we update applications across multiple nodes without ever taking them offline. Because if you simply uninstall an old application to install a new one, you get downtime. If an installation takes 5 minutes, your users are just staring at a broken error screen for 5 whole minutes. That is a massive fail. This is exactly why Kubernetes orchestration offers advanced deployment strategies, primarily rolling updates and canary deployments, to completely eliminate or at least heavily mitigate this downtime. The rolling update workflow is fascinating, and it's actually the default strategy in Kubernetes for a reason. It incrementally replaces your old application instances, which are called pods, with new ones. By default, it targets a 25% transition rate. It brings up a new pod, and this is the crucial part. It utilizes something called a readiness probe. This probe ensures the new version is absolutely healthy and successfully accepting traffic before it safely destroys the old replica. So if the new version crashes immediately, the update just halts and your old versions keep serving traffic seamlessly. The goal here is absolutely zero downtime. However, sometimes you need to test a massive new feature safely in production with real user data. A rolling update doesn't really help there since it replaces everything within a few minutes anyway. For risky new features, you use a canary deployment. By configuring an ingress controller, you can route exactly 10% of your live user traffic to the new version, while 90% stays safely on the old, stable version. This gives you a severely limited blast radius. If the new version completely fails, only 10% of users are impacted, and you can instantly route them back. But if it succeeds after a few days of active monitoring, you can confidently dial that traffic up to a full 100%. Section 3. Visibility. Monitoring with Prometheus. Okay, so our applications are deploying beautifully across our clusters now. But as our clusters grow to hundreds or even thousands of nodes, how do we know they are actually healthy? How do we know if a bad deployment is silently eating up all our memory in the background? We desperately need visibility. This is where the open source tool Prometheus comes in. Prometheus actively connects to the Kubernetes API server and it scrapes exposed metrics. We're talking things like CPU loads, memory usage, or pod statuses. It takes all of this raw data and stores it sequentially in a time series database. And crucially, if a metric crosses a dangerous threshold, it forwards that issue over to an alert manager, which can instantly ping your engineering team on Slack or via email. But let's be honest, staring at raw JSON data isn't great for human eyes. While Prometheus does all the heavy lifting of gathering the complex system metrics, it's almost always paired up with Grafana. Grafana uses Prometheus as a data source, and it translates that incredibly dense data into beautiful, human-readable charts, graphs, and visual dashboards. But there's a problem here, and it's actually a really big one. Standard observability, exactly like we just discussed, is fundamentally reactive. You are setting up monitors that only alert you when a system is actively failing or has already reached a critical, dangerous threshold. Getting a Slack alert at 2 a.m. that your CPU is pegged at 90% means you are already in a crisis. Cue the blind panic while you fumble for your glasses in the dark, because honestly, by the time you boot your laptop and log into your terminal, the server's probably already down. Section 4. The future. Predictive AI Ops. Let's look at how all of this builds into the absolute most cutting-edge layer of our maturity journey. What if we didn't have to react to the storm at all? What if we could let AI predict the storm before it ever even hits us? This is AI Ops, or Artificial Intelligence for IT Operations. Instead of waiting for a server crash, AI Ops platforms ingest the massive amounts of historical metrics, logs, and traces gathered by tools like Prometheus. They use advanced machine learning algorithms to identify strange, really subtle patterns that a human would literally never notice, and they actively forecast future bottlenecks. It's exactly like a weather prediction app for your servers. Just like a weather app uses historical atmospheric data to warn you that it's going to rain next week, platforms like Dynatrace Davis or ManageEngine Zia feed on your observability dashboards to warn you about the future. They can look at a tiny, microscopic memory leak and predict, with incredibly high accuracy, that your application is going to completely run out of memory 10 days from now. To show you just how incredibly powerful this is, let's look at a real-world example detailed in our sources. Using ManageEngine's Zia platform, the AI successfully flagged 66 confirmed future anomalies that were hidden inside a staggering 1,085 active monitors. Think about that for a second. Absolutely no human engineer can manually track over 1,000 different dashboards simultaneously to find these microscopic spikes. But the AI, it does it effortlessly. And the ultimate future state, the holy grail which the industry is building toward right now, blends traditional predictive AI with generative AI. It works like this. The traditional AI forecasts the issue, saying, hey, we will run out of memory next Tuesday. Then a generative AI agent reads that prediction and autonomously reaches out to your Kubernetes autoscaler, instructing it to add more memory nodes before Tuesday ever even arrives. Zero human intervention, absolutely zero downtime. As you continue to build and scale your own systems, I really want you to remember this journey, going from typing basic Linux commands in a terminal to gracefully orchestrating deployments, to visualizing raw data, and finally graduating to AI foresight. Ask yourself right now, how proactive is your infrastructure truly? Are you still just waiting around to react to those 2 a.m. Slack alerts, or are you predicting the storm? Thanks for joining me on this explainer. I hope it completely shifts how you view and build your systems.